Hey guys, this is Statistical Applications. Our objective today is to demonstrate understanding of correlation. So at the end of this, you should be able to state what degree of correlation A, B, and C are. You should also be able to describe a line of best fit, and you should be able to say what R equals 1, R equals 0, and R equals -1 means. Okay, so correlation. Correlation is just the relationship between two variables. When we talk about two variables, we're talking about the independent variable, which is the x value and is always on the horizontal line. It's usually some type of measure of time, so like seconds or the age of your population, stuff like that. Dependent is always reliant on the x value, and it's the y value, and is always on the y-axis. So these are the different types of correlations we have. We have positive or strong positive correlations, moderate positive correlations, and weak positive correlations. You also have strong negative correlations, moderate negative correlations, weak negative correlations. Strong correlations are really, really tight around a line. So there's not a line here, but I could draw one, and most of the points would either fall on it or really, really close to it, right? So that would be a strong positive correlation. A negative correlation, of course, would go in the negative direction, but still follow that same thought process, right? It's close to whatever line you put through them. Moderate, most of the points fit on it, not all of them. Some of them are off of it. Same thing with the negative. But the weak, most of the points are off of the line. Same thing with the negative. Most of the points are off of the line. Moderate, you have most of the point, or not most, but generally most of the points can fall on the line, and strong, a lot of the points fall on the line. Okay, so there are two more types. There's no correlation, so there's no pattern in this data, right? I can't find any line that can go through them, right? It's just nothing. And then you have nonlinear correlation. So I can see a pattern, but I don't have the name for it, right? Or, well, this one we do. We know it's parabola. So this is a nonlinear correlation, and that's all we need to know for this section. The line of best fit is a line that represents the data, right? So I took the moderate negative correlation, and now all I have to do is put a line that generally goes through most of the points, and it's not going to let me do it, so let me, I don't have here, okay. So, nay. Okay, so I drew a line that goes generally through the data. There's a good amount that are above the line and a good amount that are below the line, right? So I have 1, 2, 3, 4 above the line, and 1, 2, 3, 4 below the line. You kind of want it to be even, right? Same amount above the line, same amount below the line. But that's what a line of best fit is. Now, the good thing about the studies class and your test is that you can actually use your graphing display calculator to find the line of best fit, so we don't have to go through and try to find one. I will show you that on Friday when we meet again. And then there's this dude, Carl Pearson. He is like my father from another mother, or my brother from another mother. Yeah, so he made this coefficient that talks about how well a correlation is, right? It's called the Pearson's product moment correlation coefficient. We are not going to call it that. We are just going to call it the correlation coefficient, because that makes sense. Sorry, Pearson. We're moving on. So it's represented by R. So whenever you see R, think correlation coefficient. okay? The correlation coefficient, R, is between -1 and 1. If you ever get something outside of that, so if it's -2 or 1.1, that is not a correlation coefficient, okay? When R equals -1, this is a perfect negative correlation. That means every single data in the population or in your set falls on a line. And it's not like a little bit off or anything like that. It is perfect. Whenever you have a 0 for R, it means that there is absolutely no correlation, none whatsoever. Now, when R equals 1, that means you have a perfect positive correlation, okay? Whenever you have like a strong correlation, you should have like a 0.92 for your R. Whenever you have a weak correlation, it's going to be closer to 1. It's going to be like 0.2. Okay, that's a weak correlation. You always want something closer to the 1 or the -1 in order to get a good correlation, in order to draw conclusions on your data. So I'm really sorry. I just realized I was talking really fast throughout this. Go back and rewatch it. It's only 6 minutes and 30 seconds. So yeah, a lot of this stuff, the reason why we're not going deeper into it is because it's mostly on your GDC. Like, I don't want to give you a bunch of formulas and stuff when you don't need them. So, yep, have a nice evening.